Hello, welcome to the Deploy AWS vSRX instances using Terraform Learning Byte. I'm Gordon Mosley with the Education Services Department at Juniper Networks. Let's get started. After watching this Learning Byte, you will understand how to deploy AWS vSRX instances using Terraform. Many organizations leverage services offered by multiple cloud providers to meet the needs of their customers and their employees. Deploying resources across multiple cloud providers is a challenge because each cloud provider provides their own unique solution for infrastructure as code. The ability to define resources in a file, provide that file to the infrastructure as a code service offered by that cloud provider, and use that file to create and destroy resources. For example, Amazon Web Services provides CloudFormation. Microsoft Azure provides the Azure Resource Manager. If you are an administrator trying to instantiate or manage resources running in these multiple cloud environments, you're challenged to learn these unique tools offered by these unique providers. One solution multi-cloud administrators leverage is an open source infrastructure as code tool created by a company called HashiCorp. The software solution is called Terraform. HashiCorp defined their own infrastructure as code configuration language called HashiCorp configuration language. I'm allowed to define my cloud resources in HashiCorp configuration language and store them in a Terraform file. Terraform provides plugins that can take the resource definitions defined in the Terraform infrastructure file and the plugins can convert those instructions, those resource definitions, into definitions that are understood by over 200 different cloud providers. So as your cloud grows more complex, this solution offers you a little bit of simplicity. One tool that can manage, automate, and orchestrate resources across multiple clouds. And in this Learning Byte, we're going to leverage Terraform to instantiate a vSRX instance in the Amazon Web Services. This is the actual infrastructure we will deploy. We will create a virtual private cloud. We will use the 10.0 subnet block. There are 4 elastic interfaces that are created that represent the management interface and 3 revenue interfaces on a vSRX instance. There are 4 subnets defined. There are route tables, security groups, and all of this infrastructure will be automatically instantiated by simply using Terraform. To use Terraform, I have a Linux management workstation that I installed Terraform on. It's a very simple installation. You simply download Terraform and unzip a binary file called Terraform, and you need to copy Terraform to somewhere in your path so you can simply run the Terraform command. Now I'm going to connect to that management workstation and I'll show you the Terraform infrastructure file, and then we'll use that file to instantiate these resources in AWS. This is my administrator workstation, and this is my Terraform infrastructure file. It's called Deploy AWS, and it ends in a .tf extension. Now, this file will only launch resources in Amazon Web Services. So these resources are defined in a way that the Amazon Web Services plugin from Terraform can understand and translate into something that AWS understands and build all of these resources. Now, one thing that has to be created before you can launch Terraform to create the resources is you need to create a programmatic access key for your account. When you log into Amazon Web Services, you provide a username and password typically. You can associate a programmatic access key with that account so automation can authenticate and perform the same functions that a normal traditional administrator could perform. So in Amazon Web Services Administrator Portal, generate a programmatic access key for your account, and then copy the actual key and the secret key values into your Terraform file. So when this is processed by Terraform, Terraform can connect to AWS and authenticate using these credentials. I'm going to create resources in the Amazon Web Services US East 1 region. And then I list in the rest of the file contains the actual resource definitions. Here's my virtual private cloud, the CIDR block that I want to assign, the 10.0 CIDR block. I give it a name. And then, there's security groups that you define. And this is the challenge when you're just getting started, is understanding how to define all of these resources. I was able to find examples that got me started and able to modify the values to meet my needs. But there's security group rules. In this file, you'll see the AWS key pair that's used for authentication, any subnets that have been defined, interfaces. So this is infrastructure as code, right? All of the resources that I do want to create, instantiate in AWS are defined in this file. So instead of doing this manually piece by piece using the AWS portal, I can do this in a much more rapid, consistent, scalable manner using Terraform. And then I can apply this knowledge across a range of cloud providers around the world. Let's process this file using Terraform and instantiate some resources. Before Terraform can actually initialize or instantiate any resources in AWS, I need to initialize Terraform. And I do that with a Terraform init command. I have the TF file here in my home directory, and so it will find any Terraform infrastructure files, and it will process that file, which means it loads the AWS plugin so we can process the file. It will analyze the contents, all of the resources, alert me of any errors, and any errors means this file cannot be processed by Terraform. Warnings are generally okay. They identify, hey, this syntax may be deprecated, and going forward you may have issues, but we're good. So the resources in this file can be processed. My next step is to create or to run a Terraform apply command. This again further processes the file, generates what's called a Terraform plan, which will show you all of the resources that would be created if you continue with this deployment. Now I'm going to scroll up a little bit because there's some output that might interest you. And again, this is a Terraform plan. I can run Terraform plan if I just want to see the plan, but it lists all of the resources. The plus symbol means this resource would be added to your infrastructure. A minus sign means this infrastructure would be destroyed if this plan was executed. And so I'm going to scroll back down to the bottom, but again, it's all of the resources that are present in that infrastructure file. This is what will be created after I run a Terraform apply and answer yes. Now this begins the process of connecting to AWS, using the AWS plugin, and creating all of the AWS resources. Now this can take a few minutes for these resources to be created and the actual vSRX instance to be instantiated. And so I'll pause the video and we'll come back and look at the actual results. All right, that should be enough time for the resources to have instantiated. Now what you can see here is a list after you run the Terraform apply and say yes, a list of all the individual resources. For example, the actual interfaces that are going to be used by the vSRX instance, the elastic IP addresses, the route tables. And so 23 resources were created in Amazon Web Services by running this Terraform, performing this Terraform operation. Let's go look in the AWS portal at the resource. Here's the actual vSRX instance that was instantiated. Now I can click the instance and I can see some information about it displayed. I can see, for example, any elastic IP addresses that have been assigned, private IP addresses. I can scroll down and view information about here's both of the elastic IPs. One elastic IP was assigned for the management interface, and another elastic IP was assigned for a revenue port, so customers can access the resources that this virtual SRX is designed to protect. And so you'll see, if I scroll down, the individual components that are required to launch a vSRX instance. For example, network interfaces. This is the management interface. I'll scroll over. I can see the other additional interfaces that were created. Here's the public IP addresses that have been assigned, the private IP addresses that are used are assigned to the interfaces as well. So all of the individual components were built dynamically using Terraform. I didn't have to, here's the elastic IPs, I didn't have to build any of this manually, and that's the benefit of this. Now let's use Terraform to tear it all down. The Terraform destroy command will destroy, as the name says, all of the resources that were created with the apply operation. So let me scroll back up. Remember previously when we did the Terraform apply, all of the resources that were going to be created had a little plus symbol by them. Well, the destroy operation is the exact opposite. These are the resources that will be destroyed. Once I confirm with a yes, the Terraform destroy operation. And just as it took a few minutes to instantiate or create all of those resources, it can take a few minutes to completely destroy all of those resources in AWS. But doing this deletes all of the resources that were created, and the benefit to me is it stops the meter running. I won't be charged for those resources after this operation completes. You can see it's beginning to destroy the vSRX instance. The supporting resources seem to already have been or are in the process of being destroyed. All right, the Terraform destroy operation has completed successfully. Now to verify, I'm going to go return to the AWS administrator portal. Go back up and we'll click on instances. And the instance will probably still appear in the list, but it should show a terminated state. I just was at the elastic IP addresses. Let me click on those again. And those resources as well, if I refresh the display, have now been destroyed, as well as the network interfaces. Let me refresh this display, and you'll see the network interfaces have been destroyed as well. So this is an example of using Terraform to instantiate AWS vSRX instances and their supporting resources, and then using Terraform to destroy them. In this learning byte, we deployed AWS vSRX instances using Terraform. Thank you very much.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.